Oops, panic. Hello world, welcome to Decode or Not Decode. I'm merely Eva, and joining me as always is the .NET wizard, Stefan. How are you doing, Stefan?
I'm doing great, but I already made a mistake. I closed the console window too early.
No, that's just good that you started us off like that, because usually that's my job. So yeah, thanks for taking that burden off me. But yeah, for those of you who are new here, Stefan and I are two friends with a shared passion for coding, and we've been building something incredible using C# and .NET in our live streams, which occur every other week. And yeah, it's been a great ride, especially for me as a coding newbie, learning from Stefan, who's got plenty of experience. I think, what is it, 10 plus years? I always get it wrong, and even though I say it like every other week.
Pretty much,
Yeah, but no, we're super excited to be with you today. So big thank you as well for the C# Advent Calendar for having us. If you'd like to learn, any like something C# related during the Christmas period, check out all the wonderful content on here. I'm sure there's something for everyone. It's loads of creators, and I even saw that there's even an archive, so you can even go back a couple of Christmases. Like there's literally you'll find something really cool to learn, and we're on there as well, so thank you so much for having us. I think let's talk a little bit about what we did in the previous episodes, because this is actually our last stream of the year. What have we been getting up to in the last couple of episodes? We've love and lines of code. We've been crafting a .NET tool. And we developed features like the using counter, the using globalizer, and the interceptor locator. And we will show you exactly what those features and our tool as a whole do. But first, we wanted to get some concepts in. and so just to make sure that we're all on the same page with a couple of concepts. Is it okay? Yeah, maybe we can jump. We're connected via live share, which is super fun. And let's try and get on the same. I'm going to try and follow you. Where are we? We're in program CS. Oh yeah, so this is just like an empty file, because I wanted to talk to you a little bit about using directives, because I mentioned that our tool has like the features using counter and the using globalizer, but what are those usings? So I am.
Hold on a second. I forgot to disable something that gives away. That gives
That gives
plot
away
twist.
something.
No.
The plot twist. Oh God. Call the fire brigade. No, it's okay. I think we can still make it work. But yeah, okay. Let's start. I said I was a coding noob, but I think everybody who's ever like written any line of code. Where are you? Oh my God.
So in the programs, yes.
But I was there as well. I was following you.
Oh
God.
Is that?
No, you can't see my stuff. Can you? Can you click somewhere in the file?
Yeah, I'll jump to a different file and then back to that one.
No.
Uh-oh.
So many technical difficulties. I think like maybe the stream is also in Christmas mode. Let me just write something again, but you can't see it, right?
No, I'm afraid not. Can you quickly try to reconnect?
Yeah, absolutely.
Give it a good
Should we then? Okay, should I do that and then you talk about the concept that you wanted to share?
Yeah. Let's mix things up. So let's first talk about interceptors. Interceptors are brand new in C# 12. Well, in the compiler that supports C# 12, and they are experimental, but they are also already in use. They're a bit of an implementation detail, but we can already take a look at them. If we have the .NET 8 SDK installed, there is a new template that you can select from, the ASP.NET Core Web API native AOT template. Native AOT stands for Native Ahead of Time Compilation. Native AOT Web API, which is in contrast to JIT, Just-in-Time Compilation. where we don't have, in an AOT scenario, we don't have the JIT, the just-in-time compiler, available. But some features in a lot of applications, for example, in ASP.NET Core, require just-in-time compilation. For example, the map get methods here. So this is the default template. Basically represents a to-do application where we can list all to-dos in the root page, or pass in an ID of the to-do and then get more details about this to-do. For example, I still have to do to-do 3, do the laundry this year, 2 times maybe, but let's see. And we
Get all the Christmas sweaters clean again.
Yes. I don't have a Christmas sweater, actually.
I do. Yay. I got one last Christmas. It was my first one. Okay. I know what I'll get you for Christmas.
Oh. And if we take a look at the map get method and browse to the source code, eventually what it will do is it will emit at runtime new IL code. So we have in C#, we have our C# code that's in a CS file. Then this is compiled via Roslyn. This is the .NET compiler platform that compiles both C# and Visual Basic Code to IL code, intermediate language. And this intermediate language is very portable. It can run anywhere where .NET runs. So we can deploy this IL code to a machine, for example, to a server, and then run this IL code via just-in-time compilation, where just-in-time we create the right platform-dependent binaries, like, for example, Win64 or Linux 64-bit or macOS 64-bit or 32-bit. But what if we don't have not all environments have the JIT available, but also the just-in-time compiler is a bit of complexity because there is compilation going on. We first need to compile, translate the IL code into machine code. And this comes with a bit of a performance hit at startup. Now, that doesn't mean that the JIT is slow. It's actually super fast and super powerful. In some scenarios, you do want to have the just-in-time compiler because it's really great, especially in .NET 8. But maybe we can't use the JIT in all scenarios. So if we don't have that, or if we don't want to pay this first startup hit that the JIT causes, we could do ahead of time compilation, where after compiling the C# code to IL code, we are ahead of time compilation, we can directly compile it to the machine-dependent code. And then we no longer ship the IL code, but we ship the final machine platform-dependent binaries. So this is no longer super portable, but it is ahead of time compilations. It's ready to run. It doesn't require the just-in-time compiler anymore. But map.get does something called reflection.emit. So this at runtime emits new IL code that is then just-in-time compiled all at runtime. But if we don't have the JIT available, we can't use that. But this application will still work in scenarios where we don't have the just-in-time compiler available because of this new flag, publish AOT true. And web APIs are now in .NET 8 to some degree. There is limitations, and it will take more time to support all scenarios, but currently this basic scenario with minimal APIs is supported in .NET 8. More scenarios will come over subsequent .NET releases. And what this does is, well, we can't use map.get, but we need to replace it. And there is now a source generator kicking in that emits this attribute. I will copy that because we need that later. And applies this to some methods. We have here the map.get0 method. And scrolling down, the map.get1 method. And what we see with these methods, they have the same signature as the original map get method, and also now have this attribute. And this attribute specifies a location, so exactly where we want to intercept the call. So this is the interceptors feature. We want to intercept a method invocation. This currently only works for methods. That is in the program CS, it's up here, at line 21, character 10. And if we take a look at our code, line 21, character 10, we also see this down here, line 1, character 10 is selected. This is exactly here. So we now intercept this invocation, and we no longer go to, when we hit F12, we no longer go to the method that is defined here in this endpoint root builder extensions from ASP.NET Core framework, but it is intercepted. So the compiler at compile time does a little sleight of hand and reroutes this invocation to this generated invocation here. And now this code is executed. And this is a special case for this method, and it shifts all the runtime complexity to compile time complexity to enable the AOT scenario, because this code now avoids the reflection emit calls to make it AOT compatible. And the same is happening with the other method. If we scroll down to the map get one, so the name doesn't need to match, but the signature requires to match, and also the return type. We now intercept line 22, character 10, which is now the very next line. And since it's a source generated, it's very cool. If I add 2 more lines, now the generated code will update, and instead of line 22, it's now line 24. And let's say we add, let's put this side by side, and we see this, how this updates live. Currently, it's character 10. Let's add a couple of spaces, 1, 2, 3. Now this shifts to character 13, and we still intercept the very same method. And we can also write interceptors ourselves. Well, we really shouldn't, or we won't, but we could, because it's just a C# feature. Let's create a my class here. And this my class has a my method. And this method does a console.writeLine hello. And let's start this. Since I made an instance method, so we have a my class, and we invoke instance.my method. And when we run this application, .NET Run, it will print hello after it has been compiled. Oh no, I need to specify the framework.
Might
There we
print
go.
something else if the yay! I'm back in live chat.
Cool, excellent, nice test. And now let's basically do the same thing. Let's intercept this invocation. So what we need is this attribute. This attribute is not part of the BCL of the base class library yet, so we need to emit this attribute ourselves. And now let's basically copy this type, but let's call it different. This will be now my interceptors. This will be a static type. And we have, the name is irrelevant. Let's call this the interceptor method 0 or something. It needs to have this matching signature, so we make sure that it's the matching signature. Now, this is an instance method, not a static method. Therefore, we need to pass the instance that we want to basically extend on as a this parameter to make the signature match. And now we can, let's print intercepted a C# advent calendar instead. Currently, if we run it, we still run the original hello C# advent calendar. Nothing has changed yet. Now we don't update the call side. We just add this interceptor attribute to here. We need to specify the location, the line, and the character, the column, it's called. Now the location we get by copying the full path. It needs to be the full path of this program CS file. Oops. Copy full path. Needs to be a string. And this invocation here of my method is at line 8, character number 10. So let's specify line 8, character number 10. And this gives a error because it's an experimental feature, it says so. We still need to explicitly enable interception for this namespace. The warning here actually says what we need to add. If we jump to the CS proj and add this, basically adds the namespace where the interceptor is in. So let's put this into a namespace .interceptor or interceptors. This is the namespace that we need to define here. So where the interceptor is located. Now the warning we just saw disappears. And without ever updating the call side still calls into its original my method down here from a syntactic point of view. But now, since the interceptor is in place, we now call intercepted instead. And if we remove the attribute, it will be hello again. And this is how with interceptors, we can do a little sleight of hand and reroute method invocations. But it's currently not so super visible. From a caller's perspective, I don't see that this call is actually intercepted. So this is one of the use cases that our tool should display, that if there are interceptors, what interceptors are in place and where are the interceptions going on.
Awesome. Thank you so much for that. I hope I'm back at the correct place because I'm still not at the file that you're at right now.
Program CS?
Yeah. Of the tool. I don't even see the things. Can you follow me for 1 second? Just to see if you...
I do.
No, you don't jump to where I'm typing, right?
No.
It's weird because I could edit your your string, but I can't. I can't somehow access.
Would you mind reconnecting one last time? Let's give it one last chance.
I just followed you into this file.
Yeah, but I don't see your cursor or something. So can you type something?
Yeah. Hello.
Oh, okay. Cool. But you can't go into the program?
Nope.
Then let's stick in this class. Okay. Let's just modify the my class here. Now this is our context.
Oh, is it? But there's so many usings already up there. Wow, let's just delete everything on the Christmas episode. Let's just get rid of everything in one file and let me explain something about usings. That sounds like an awesome idea. Famous last words as well. But yeah, I wanted to talk a little bit about usings. That's what we've been working with for the whole kind of year. Can I also get rid of... No, I just want to first start like really, really basic. No, I should write in here.
Well, only if we were in the pro. Hold on, if we remove that. No, actually, we should be able. Let's get rid of that.
Okay, so well, we actually have. No, we can don't. Oh.
Now we should be able.
Okay, cool. Well, let's get like a method back that we kind of used before as well. Okay. Because it's not compiling, right? Because it's not the full name and we don't have a using. So we need to write it by call it by its full name, which is system.console.writeLine. So there's something that I didn't write, Stefan didn't write it, somebody else wrote, and we can borrow it if we know the name. And obviously this gets like super tedious, is like especially if you have it like multiple times in your file, in your project. So this is where top level usings kind of come into place, because obviously if you have a a top level using, so like using system, for example, you can actually get rid, and it already like grays it out here. These are no longer necessary. You can just do console write line, saves you code, saves you trouble. You don't have to specify it every single time. So these are the top level usings that our tool is working with. You look unhappy, Stefan. What's up?
No. I'm just centering myself to the camera. So
the thing is, basically everything I know, like Stefan taught me. So like whenever I like see a certain look on his face, I'm already
no.
what did I do? But yeah, so this is this is top level usings for you, which is what our tool kind of works with. But I also wanted to show you. Let's comment this out again, because we can also like have it have nested usings. So like in this namespace, I can also declare my using, and then it works, which is great. But if I have like multiple namespaces, even like in the same file, I would have to declare I would have to put the using in also like in every single namespace, because even though it's just above it, this line of code doesn't know about using system. So it's like, what are you talking about? I don't know, console write line. And I'd have to again sort of put the system either here and call it by its full name, because that always works, or I'd have to sort of have this nested using within every single namespace like this. And yeah, so, but I think, let's go back to our top level using, because kind of also what we get into further along this episode is global usings, because using system is something you will use in almost every file of your project, and it can be a large project, a lot of files, a lot of code. You don't want to write it maybe every single time. So what you can do is to have a global using file that I don't have here. Wait, we practiced this so well.
Do you see that? Oops.
No.
Oops, I closed it again.
Maybe you have to write all the globals then.
Do you see that one?
I can't follow you. Nope. But can you just write global using system?
Global using system. There it is.
There it is. And now I don't have my top level using, so but I can still just do console.writeLine, because now as a global using, it's actually implicitly like put like there for every single file for you to use.
So if I go to a different file, I can also say, I'm now in a different file, I can also say console.background color for some reason, because let's set it to
red.
Red.
Oh, Christmas, yes. Come on.
And it works, yes, without having the using specified. So it's now in every document I see. Cool.
Yeah, that's sort of the really, really cool feature. But there are even more usings that I would like to sort of show you as well. Because, for example, if you can like get rid of the global using again, we'll get back to it, but we go back and forth between the different types of usings. And for example, like we were talking about, like you can write system here, but it's a lot of code. It's a lot of code duplication, and we also have console and console there. So we can actually have static usings, which import all static members of system console, for example. So let's see what that looks like. So it's again using static, and then we want to have, what is it, system dot console. Oh my god, and I do have the autocomplete, which helps me not do typos, which is something I love to do. And and now we can actually get rid of the console, because we've already got it in our using. So again, we got rid of some code. It's more readable, it's prettier, and Christmas is all about pretty things, right? Sparkly and pretty and wonderful, just like that. So they are called static usings, and you can also have global Oh, that's not it.
Oops.
That was nothing. I forgot about it. We can also have that globally. So if you could again go
Yeah.
to this and now have a global static using system dot console.
Oh, yes, that's right. Global static using console.
Global static, global using static.
Yes.
Sorry.
Mm-hmm.
Yes, and now again, you've got it, the same sort of logic, but applied to every single file.
So if we go to the other document, then again, we can get rid of console and just have, well, console. Okay,
Well,
console color is not. Could we also,
yeah.
actually don't know, because console color is an enum. Does it? That's not a static member. Does it also work on enum? I don't think so. I actually don't know.
Let's try.
Console color. No, that's an. Does it also work on enum members? Oh wow, I did not know that. So we can also background color equals red. So that's the background color of system.console and the red of system.console color. Cool.
Yeah. Yeah, it's pretty awesome. I do have one more though that I'd like to show you. So potentially we have to get rid of the global using the static global using again. Because sometimes you have different packages in the same namespace that define the same type, or like a type with the same name. So you want to give it a different name to avoid ambiguities. And so this is why we have aliases. So for example, if you have like, we've got, let's again, yeah, we have write line here, but we maybe have, also have like we wrote our own method that's called write line and it's ambiguous. So I can, for example, tell explicitly that I want to use system.console as, something else. So for example, if we're using not system.console, but let's have another name for it. For example, printer. I think in some other languages it's like print, not like write line or something like that. So this is why it sort of came to mind. And we can say this is supposed to stand for system dot console. Oh my
Careful,
God.
there's a typo in the system.
Again, system. Oh my God. This is why autocomplete is your friend and mine as well. And now we can actually use not console or write line, but printer.writeline. Oh, copy pasting. Eggplant in training will be proud of me and any other regulars who are here today with us. All right. And so, yeah, so now we can call it printer.writeline. We don't have any ambiguities should we have any other methods with the same name here. And you can also globalize that. Who would have thought? There's like, you can maybe already detect like a theme. So I put this away again. And would you be able to go back into the global usings and write global using printer is system.console. And now again, we have it here and we've saved a lot of space. It looks really pretty, really readable. No ambiguities, nothing like that.
So we can also use this in our other document where we now say printer.background color is, let's also give this enum a different name. Let's call it something because I can't think of anything better. That console color, and now we have something.red. Cool.
Yeah, it's actually really cool. I like it. Cool. I mean, we've talked a lot about usings, but also because we talked about aliases and stuff, I just wanted to show you one more thing, which is type using aliases. I think they're called a C# 12 feature. And you can also, like, just as we did with this alias, wait, do I now have to put that in here, or like, can I put it anywhere? Let's put it in a method. Why not, right? Or on the top. Can I put it to the top? Where am I? Here. You can also do this. Okay, so for example, if we have like the type int, but we don't want to call it int, we want to call it something unique and special and Christmassy. So we can say, for example, using number as int. And now, how can we show that best? So
can we also call it year?
Year?
Yes.
Yeah.
So that we can use like year here. Oops.
Oh,
And we do some string interpolation and add the year at the end of the string.
nice.
So we can now, but it's still an int, is it?
It is. It works exactly as an int, but it's called year.
Cool.
Yeah. Yeah. All right. And we can also do that with, for example, with tuples.
Mhm.
Tuples.
Actually, I'm not sure how they're pronounced correctly.
Yeah. But for example, you can have using my tuple. I'm going to call it tuple because I like it like that better. And then you can kind of, for example, define like an int and a string. And that's the tuple that's now called my tuple. Tuple is, I now changed it like in the middle of the sentence. Awesome. And you can not only do that, but you can also give this int and this string a name. So it can be, I don't know, number and text. Very creative today. And yeah, and now we have a tuple called my tuple with number and text.
Seems to be Eggplant Training is suggesting or has did some
Tuple?
research. It seems to be tuple.
Tuple.
Tuple?
Awesome. This is why we love to have like this live stream with like our community, because they help us out so much and
Oh, yes.
fix our problems. And especially, yeah, thank you to Eggplant in Training, who's sort of like, yeah, taught us a lot over the years as well. And your salty
Indeed.
devil.
Yes,
Hello.
what did I do?
Cool. There is one more thing that I think you could potentially show as well.
Yeah,
And
I'm
you
not
kind
wondering.
of showed it. Oh,
Also,
go for it.
yes. Oh, yes. I know. The implicit usings.
Yeah, you kind of gave it away a little bit at the
Gave it
start
away.
of the episode because we sort of tried it out before, and yeah, and we forgot to change it back.
So now if I enable it, can we say console here again?
Yes, we can absolutely. So what does this do? Oh,
Oops.
console like this, right?
Yes. I'll also get rid of the global usings.
Yep.
And now it shows as full. Yeah, but it's available, but we do not have system declared either locally nor globally.
Yep.
But was this enabled? What this is doing is actually giving us generated by the compiler. We see that this is in a document called .g.cs. Generated those 7 global usings that are very prevalent that almost every project is using. So we got system. We also got collections. So can we create a list without specifying using system collections.generic?
Sure. Try it out. Why not?
So we could say a list of ints or a list of years.
Ooh.
Those are my years, and just say C# 12 style, make it empty. Or let's add. What is it? I think the C# Advent calendar has 2017 and 2018 and so on. And up until 2023. Yeah, there is some missing, but yeah.
Yeah.
Now I'm wondering is what is happening with this year. So if we put this in one of my favorite websites, into SharpLab. Okay, we don't have global usings here, so we actually need to say using system and using system.collections.generic, because the global usings the implicit usings are not enabled by default. We now see that this year here is still just an integer. So if we would call this spoon, then we see that there is no spoon. It's just an alias. It's syntactically different, but semantically, it's still the very same integer.
There is no spoon. I like that.
And we're being honored. Matthew is tuning into our live stream. Thank you very much for joining.
Thank you so much for joining.
one of the co-organizers of the C# Advent calendar.
Woohoo!
Now I lost my train of thought.
I think I'm done. Like, I just wanted to explain to you a couple of concepts that will be useful when we're jumping into the tool that we built over the year and that we're now going to.
Ooh, yes. So we're gonna publish this live
Yes,
and hope that our
which is
pipelines are
so
working and
scary.
everything. So we have some we did like a final bug fix. We applied a final bug fix, and now let's publish this. So this will be hopefully our pre-release number 2. So let's update from main. Okay, I guess I need to discard all the changes here. And
and put everything back that we deleted before, right?
Update from main. Yes, and push those changes to our publish branch, which should now trigger our CI pipeline that how we built that, we will show afterwards. And actions. I hope this works. So this now should be pre-release number 2. So if we jump to our NuGet feed on nuget.org, the flashover tool, we already released 2 pre-releases, pre-release 0 and pre-release 1. And now I would like to pre-release number 2 live. And so it will be hot. It should be hot off the pipeline. We see that we are using Nuke here. We will inspect it afterwards and hope that our pipeline is succeeding. So build succeeded. Okay. 0 warnings, 0 errors. That looks good. And
drum roll.
Okay, tester passing. I think we have some more tests to run because we have 2 test projects. We have unit tests and integration tests. Now I think the unit tests are kicking in. And I'm getting really nervous.
Yeah, I can
also zero
cut the
failed.
tension with a knife. Yes.
And
oh my goodness.
Actually, I should have taken a look at how long. No, it shouldn't take too long because now
we can already talk a little bit about Nuke, maybe potentially, because
let's talk about Nuke. That's a good idea.
Because we met its creator Matthias Koch on stream, and he helped us build that Nuke pipeline, and it's also a very good website with a really cool icon. That
yes, nuke.build. So what we now could do is let's jump to the root of our repository. And we can say, because we do have a local tool installed, we can say .NET tool list. And we see that we have the nuke.global tool installed as a .NET tool. And that means we can now say .NET nuke. Let's do a -- help, which prints some information about what the tool is doing. And here we have our targets defined. And one of the targets is, for example, a test target or our pack target that creates a package. This is what should be going on the pipeline right now. And then publishing this package, this NuGet package to nuget.org. There is also a really cool feature that we can show this as a -- plan as an HTML page. So if we do -- plan, this now should open a browser and show our targets and their dependencies in this HTML graph. So we have test and test. Both test and pack are depending on compile, which is again depending on a restore, and so on. And I see up there a little green check mark.
Oh my god.
So our publish, all of our targets have completed, also the publish target. So this should mean if we refresh this page, there should be a new.
Oh my god.
Maybe it takes a bit.
Yes,
but it
maybe it takes a bit.
says publish succeeded. maybe it just takes a little bit. So let's talk about Nuke, and then we check back. So this global tool, this tool, we install it as a local tool, which means it's available as a local tool. So if we go outside of our repository and try to run it, it will say, nah, not found. It's only available locally.
Again, the concept global and local.
Now,
just
oh yes, that's actually used in multiple places, and that's because if we take a look at our folder structure, in the root of our repository, we have a .config directory, and this .config directory is a .NET tools JSON. And in this, we define the version of the .NET tool that we want to use locally, and also the version. And we can go again to NuGet.org and see this NuGet package here available in that version that we are using. And we also consume nuke.common, which is a library that basically enables now code to define that then the global tool can interact with and execute. So all of our targets we defined here. So we have the clean target that we saw, and the restore target, which restores all NuGet packages, the compile target, which builds our projects, like our test target, where maybe let's go into this target a bit more. It depends on compile. So we first need to build before we can test. And then we execute .NET test, where we set the solution file, we set the configuration, is it build or release. If compile has finished, we don't need to build the project again because it was already built. Therefore, we can skip the no build. We can enable no build to skip the build. We also enable no logo. So because of the pipeline, we don't really need this information. And we also set our result directory. And this result directory, we specify via this syntax here. We have absolute paths. We have our root directory. And we have in our root, we have an artifacts folder. And in this artifacts folder, we have our test results. And we can do this nice with this. It's actually the division operator. But Nuke is overloading this division operator to make it look like we are concatenating a path. And it does the right thing. So if we're on Windows and on non-Windows systems, which use a different directory separator, it's doing the right thing depending on the platform. And we also have some secrets, like our NuGet API key that we use to hopefully publish our package to NuGet.org, and also some parameters that come via a configuration file, like our version prefix and suffix. So if we go into, that's in config, now parameters, we see this is our prefix and our suffix. So we're currently on version 1.0.0 pre-release number 2. And I guess this is the most important parts about. There's one thing left. We also define GitHub Actions. So we have now this C# code that we can run locally. So we can actually step into our build pipelines, and from that C# code now generate YAMLs. That, for example, our publish pipeline looks like this. This is a YAML for GitHub Actions that again then eventually runs into the code that Nuke executes. So it does the same on the CI system as it does on our system locally. So debugging pipelines becomes now actually possible.
Awesome.
And this should result in our package now being listed and available. Yes, it worked.
Woohoo!
There it is.
Perfect.
And now let's take a look at our tool.
Yeah. Let's see what we built.
But let's install it globally so that it's available on the entire machine. We can do that via .NET tool install, and now pass in the name flashover.tool. Now this will fail because we don't have a stable release yet. We only have pre-releases. So we need to include the pre-release option here via -- pre-release. And now this should install the latest pre-release 2 of our package. And it does.
Woohoo.
If we now do .NET tool list, all of our global tools, it's now not available. Oh, I installed it because I installed it locally. I forgot the global the global option. So let's uninstall it again. Let's install it, but with the -- global option. So we actually install it globally. And now if we list all global packages, now we see it's available via our flashover command. And now let's try one of these features that we have explained. Which project shall we have a look at? Which one? Like for the usings, let's go into our source directory.
Yeah.
Where do we have the most code? Maybe let's jump to libraries, because there is some production code. I guess our core library is pretty sizable.
Yeah, sounds good.
And let's run flashover. Well, first let's see --help.
Let's see. Yeah, let's get some help first.
What we can do. So we can list a version. We can ask for help. I totally forgot what we have in the about. I think it says to code or not to code. Does it?
That is the question.
And we also added an info that shows that the .NET Core SDK that is selected by our tool. So basically a bit of potential debugging. We are selecting the latest .NET 8 SDK. And now we can use the usings command. Ask the usings command for some help. We can count and globalize usings. So let's count some usings. And this will now analyze our project via Roslyn, the .NET compiler platform. So we're basically using the same tools that .NET Build is using to build the project and so on. And we see that we are using Microsoft Code Analysis 13 times.
Wow.
We are using System Connectors Immutable 6 times, and so on. And perhaps since we use code analysis so often,
13
maybe
times. And 13 is also an unlucky number, so we should get rid of that.
Ooh,
so we should totally. Yeah.
So we can globalize that. We use the globalize command. The globalize command now takes the usings that we want to globalize as an argument. And I think this is it already. If we run that, this should now move, it says, 13 occurrences of the using directive Microsoft Code Analysis were globalized to the global using.cs. Now, if we take a look
did we have a global usings.cs beforehand, or was that also?
I don't think not in this project, because if we take a look at the diff from GitHub or the local diff, we see that this global usings now was newly created.
Yep.
And it contains the Microsoft Code Analysis global using.
Nice.
And all these documents, if we scroll through them, we see all of them now have the Microsoft Code Analysis removed. Which now means, have we tested this ever? If we count the usings again, now the Microsoft Code Analysis actually should be gone. And it is.
We have removed the unlucky number. Success.
We could also go crazy and globalize. So we can.
I was going to say.
I think we can globalize multiples. So if we say let's globalize C# and C#.syntax, I think we can even pass multiples. I should know we built it. Yes. So we even can globalize multiple in one go. Now we have the 3. And we can also globalize everything.
We have those 3 in the same file. Like we didn't create a new global usings file.
Yeah, that's right. So we detect if the file already is existing, yeah.
Yeah.
But now if we try to globalize all of them, we get an error saying that, okay, I see we also print the exception, what's that? Call stack of that stack trace. Stack trace.
Yeah.
That's it. I guess we should remove that.
Yeah,
I'll
could be
open an issue
something for
afterwards.
next year.
Yeah. Ooh. Remove the
Mm.
stack trace. Okay. But if we want to, we have not specified any using. If we want to globalize every top level directive, we only do top level using directives. We don't nest any we don't globalize, or we don't globalize nested usings.
Yeah.
We need to set the force flag because this changes potentially everything.
Yeah.
And
Yeah.
so
We
that's
had a
four step.
discussion. Yeah, we had a discussion about it in like one of our streams, and we were like, somebody might just like accidentally sort of like, use globalize, and then suddenly all of your usings are gone, and that might not be what you intended. So this is why we decided to put it there.
And now there is
But
all of
yeah.
I guess if we now take a look at the project, so this is our core library. In no file, okay, static usings, because we only do top level using directives. We don't do statics. We don't do aliases.
Which
But
is why I wanted to go through all the concepts before, because we only handle top level usings, which was the very first I guess concept I showed you guys.
But all the other usings are gone. Every document we see, there is no using at the top anymore. I see we do leave an empty line. I guess this is also an improvement.
Also something to optimize. Yep. We're still in pre-release. It's fine.
Oh yes. So we have content for next year.
Yeah, I never had a doubt that we'd have content for next year. That's not the problem. I remember when you decided on like what should our project be. We had a couple of ideas about the project, and then we decided on this .NET tool because it felt like the most straightforward and simplest.
Have we been wrong?
Oh yes. You live and you learn, I suppose. But awesome. I think it works really well. I'm really proud actually, because it also looks really cool. Yeah. And
let's also show the interceptor. Or is there something else you would like to mention on the?
Yeah, I mean, you mentioned
directives?
like Roslyn before, so I was also gonna talk about, because we also had some guests for that. But we can continue with the interceptors that you showed as well.
Let's come. Yep. So if we go to the native ART project that we created earlier, we can also run our flashover tool, but now using the interceptor.
Yes.
Let's again ask for help. Where we have a check and the list command, check is basically seeing if our SDK supports interceptors already. On my machine, we can do .NET --list SDKs. On my machine, I have the latest .NET 8 SDK and an obsolete 3.1 SDK installed. I should delete that. This is no longer supported. And the command now lists, okay, for 8.0, interceptors are supported, but for 3.1 does not support interceptors yet. So to see, okay, is this experimental feature supported? And if it is, we can list the interceptors or specify a project file. Are we not? Ooh, yeah, I made a mistake. I cleaned everything, so the project is gone. I need to create it again.
Yep.
Add new project. Web application 1, web application 2023. So again, a brand new project. Let's web application, go into that. Now let's run flashover interceptor list. And now this should show, because we saw earlier that there is 2 interceptors, and it should show both interceptors. And it does. So it tells us, okay, we have this call, the map get intercepted at this location. So we can jump to program CS line 21, character 10. And we also see the interceptor, which is in this case the map get 0. And the other method, the second map get, is also intercepted in the next line. This is the attributes that we saw that we that we grab the information, and this is now the map get1. And we could also group it differently. Currently we're grouping by interceptions. We can also group by interceptors, which is basically just the same information but presented differently, where we now have the interceptor as a top level structure, and so the interceptors are first, and then it shows which method, because one interceptor could intercept more than one method, at least one or many, and they are currently intercepting just one method each at this location where the attribute is defining what is so early. And what I see here, maybe we should add some colors or some more.
Yeah, we talked about it in, I think, the previous episode. I'm totally for adding colors. I'd love that. But yeah, no, basically, I think we also like had a bit of a discussion as like what would be more useful. And in the end, we said, well, both might be useful depending on whether you're after the interceptors or the intercepted. And so we just offered both, and you can use it whichever way you like.
I guess this is pretty much what we built in the last 22 episodes.
That's been our year. Let's have a look under the hood, right? Let's have a look at a little bit of code and like how we built it, and if you're interested in looking at a little bit backstage.
Shall we start at application?
Yeah, that sounds reasonable.
So, well, I guess this is our. So we have our .NET tool. This is our package where we said, okay, pack this as a .NET tool, which enables us. We can also take a look. We did publish the package earlier, so in our. No, let's do that. Let's pack the project locally. .NET Nuke pack. To create the NuGet package, and so we can take a look at it locally, how this NuGet package looks like. Because you can basically have 3 different kinds of NuGet packages. You also see this in nuget.org. When we search, we can either have a dependency package. So this is containing libraries, and so types and methods that we can use, or types and members to be more precise. Then we can pack it as a .NET tool that we can install locally or globally, or also a template. And the template is basically hooking into the template engine, so that when we do .NET New, we can basically extend this list of templates, where one of this template is the native AOT Web API template. Pack has succeeded. So we now in our artifacts folder, package directory, we have here the NuGet package that the CI basically uploaded. And the structure is, there is a tools directory. We target the currently supported .NET SDKs. And in here now is our application, our core DLLs that we removed all the usings now from, or globalized all the usings, and also some more dependencies like Microsoft Code Analysis packages. So this is basically representing the Roslyn surface area, and some more dependencies, and that's all self-contained in this NuGet package.
Awesome.
And basically, this is all enabled by pack as tool, to not have it as a regular dependency, but as a tool that can be installed. And then we call into our CLI logic. And our CLI logic is mainly built with system.command line, which has a collection of options, commands, arguments, and options, so that we get so that we can basically create the syntax here, which is similar, or we inspired ourselves heavily from the .NET Core SDK, so that it's a very similar experience.
Yeah, but we also had a bit of fun with it. I think the hash key is something with us here as well. Right?
If we go fresh, there's the help.
Oh
yes, oh yes. So this will be for information. So this should now print the .NET 8. Oops, the .NET 8 SDK. Yes, there it is.
But yeah, other than that, it's very similar to what you might be used to.
And we build up. So basically, this is here. So here is our option. So this is basically an option for the root command. We have here the option name with 2 aliases. We have some description that we also see here that gets printed in the help options. And then we define a handler. And for this info, this is now the code. So with the console color green, we print the MS build, well, the type that we have discovered, the name, and the version. So this is exactly what shows here. We have MS build. We found it in the .NET SDK because MS build could also be contained in a Visual Studio installation. And it's the .NET Core SDK in version 8.0.100. And we did this for all of our commands, basically setting up commands and subcommands. And now, for example, the using command has this is the using command, and the using command has subcommands, the count and the globalize command. Now they have arguments, like the using arguments, which, well, we showed it with the globalizer, so that's down here. Which usings do we want to globalize? And if we want to globalize all of them, then we also have the force option. And again, we specify the name, we specify potential aliases, and we specify a description. And then add these all together, define a handler, where now the handler is eventually calling. Here we have the logic. If we do not parse any usings, so if the usings length is 0, and we do not enable the force flag, now we throw this exception, what that we saw earlier, where you also have the entire call stack of stack trace, not call stack. And so I guess this is now what we will improve in a future episode to not have the entire call stack here. Stack trace, I always use this wrong. But anyway, we then call into
we know what you mean.
we then call into this logic where we are now going into the Roslyn. So we're basically transferring from system command line now to the Roslyn world. And in order to use the SDK in the very beginning, this is what our guest David Vengier showed us initially. Was this our second or third stream? But really, when we started with the tool,
no, but it was our first guest, and I was really nervous. I remember that.
Yes. We need this magic special method, which goes into a machine and finds the best match for the .NET SDK installation. Well, it's called Visual Studio Instance because previously .NET was always part of Visual Studio. Now with the newer .NET Core, it's also standalone SDK available. So to not break anything there, we still have this name. And this now, in our case, contains the information about the .NET 8 SDK, which we can use to create ourselves and did I jump over this? MS Build workspace. There it is. So we can now create an MS Build workspace. In Roslyn, we have a bit of a structure. We have a workspace which groups everything together. In a workspace, we have a solution. In a solution, we have one or many projects. This could be Visual Basic projects or C# projects. And within a Visual Basic or C# project, we then have documents. One or many documents. And within a document, we basically have the syntax tree. We can view the syntax tree via SharpLab. We had this open earlier, haven't we? Yes.
Yeah.
So we can take a look at our code here, view the syntax tree, basically see the Roslyn representation, and this is how now we analyze the code. So we get, for each document, we get a compilation unit, which is the root of the syntax tree. And here we have our four top-level using directives, which are those 4 top-level using directives. Now, those 2 are aliases, and those 2 are regular, ordinary using directives. And we now basically want to find all of these regular using directives that do not have an alias information. So we see they only have a name, but the alias actually has an alias node in it as well. So we don't want any aliases, we don't want any statics, we don't want any global usings to count. And so we now get a hold on the workspace. Via the workspace, we can get a solution or a project. So we are opening the project that we want to open, then jump into our logic. In our logic, we want to ignore generated code. So if the entire project is generated, we want to ignore that. Now we are on the next level. In the project, we have documents. We go through every document. We check if this document is generated, because we don't want to really count or globalize generated documents, because we shouldn't mess with generated documents. And then at the end, oops, I'm actually in the wrong. Let's go to the using counter. Very similar. It's also with getting all the documents. And eventually, we now are in the logic of the aggregator of the using directives that we find. So we are having here now this compilation unit that we saw in SharpLab. So we are now basically on this level and getting those using directives, from which we check, okay, if it has an alias, or is it static, or is it a global using already, we continue, we ignore it. So we only do ordinary top level using directives and basically aggregate currently, yes, and aggregate them. And then now we have went from the system command line into the Roslyn world. We got the workspace, the MS Build workspace. The MS Build workspace requires the SDK to be installed. We go into the solution, we get the project, we get the document, we get the using directives, we accumulate them, then give them back to the system command line and print them to the console. And this is pretty much our workflow, isn't it?
It is. Well done. You deserve a sip of water after all of that, definitely. Yeah, so we've talked about the using globalizer, using counter. Do you also want to have a look at the interceptor part that we wrote?
Yes. So with the interceptors, we got massive help from Jason Buck.
Yes, we did. That was also awesome. All of our, again, I'm going to say it again, but big thank you again to all of our guests here on the stream. They're not only experts at what they do, and it was really completely great to meet them, and it was an honor to meet them actually, but they also helped us a lot and helped us build this wonderful project. Right.
Visual Studio's crashed on us.
I know. I think maybe potentially next year we're not going to use Visual Studio again. It's probably because of the live share stuff. We have some issues today with that, don't we?
Indeed. Interceptors, yes.
Yes.
So how do we get all the interceptors? Again, it's very similar. So when we launch, let's go into full screen mode. In our command line, when we launch interceptors list command, we go into our application. We set up our command. So when our system command line land, we have our interceptor command with two subcommands, the check and the list. And should we do a check, a list, we basically extract information. Do we have the group by interceptors option set or not? And if we have or have not, we pass in the Boolean. Then we check, is it actually supported? Are interceptors supported? Currently, they are supported on .NET 8 SDK, but also on the .NET 7.0.400 or above SDK. I'm actually not sure what is the latest. We can go to .net.microsoft.com, get a hold of the downloads to all versions and see the currently available versions. So in .NET 8, this is the latest release, and this is the latest release of .NET 7. And .NET 6 is also currently supported until .NET 6 is supported until, well, we have it for another year supported. .NET 7 only for half a year. So I guess then we can also in our tool stop supporting .NET 7 SDK. So we check our interceptors actually support it because they haven't existed earlier. And then we do basically the same game again. We are the MS Build workspace. So we have our workspace. We get the project that we want to load. We jump into the logic. We basically try to compile the project already and see if it throws if there are any errors. If the compilation already contains errors, so if there's like syntactic C# errors, then we stop and we don't do anything because, this could falsify our results if there are compiler errors. We also support cancellation. Haven't shown that. So if we execute a command and hit Control C. Oh, I'm now wrong. Let's do a check. No, let's go to a project. Source web application. If we run that, oops, the other one, list. We can hit Control C and cancel the operation as well. So we support cancellation. And then we try to find all the interceptors. And this is what we saw earlier. We basically find every method that has this attribute, the intercepts location attribute on top. And we do this via so-called syntax walker. And what a syntax walker does is basically walks all syntax nodes. So we can basically define which syntax nodes we want to walk. For example, we would like to walk all method declarations. And then find if this method declaration actually has this intercepts location with the file path, with the line number and the character number, the column applied. This is basically what we want to find. So we find all the interceptors. And so we visit all method declarations. We get the attribute data of the syntax declarations, and we check. We try to get. First of all, we check the type of this attribute. Is it indeed this runtime compiler services intercepts location attribute? And if it is, we extract the file path, the line, and the character. So we now not only know the interceptor, which has this attribute on top, but we also know which method it is intercepting. And then we'll use this information to get a hold of the method that is intercepted as well. We then have both the interceptor and the intercepted method and link to each other and can then group it in our output. Again, now we're in the Roslyn world, so we give it back to the system command line world and print it to the console.
That was a nice image. All the different worlds working together. I love that. I'm going to remember that.
And in the last episode where we got help, we had Stuart Lang at our disposal, and he helped us upgrading to C# 12, which is now not yet, which is now a month old, I think.
Yeah, pretty much. Yeah. And he sort of showed us a couple of, new features that C# 12 has with them. And then we also applied many of them. And I guess we want to show you my favorite because it means that, people who, don't know code that well or are sort of new have to write less and have to understand less because C# 12 does it for you.
Do you mean this?
Yes, I do mean this. If you've been with us for a while, you've seen me struggle with the new operator and the different braces and params and what the different words, and I actually vowed that I'd be able to spell them out, all of them. I think next year I still have 15 days to learn it. More than that. Yes, oh my god.
I'm actually not. I think those are collection expressions. I'm not sure of the name currently either. But you basically can initialize almost any collection with that. So if we had let's say we have a string array, we can say, give me an empty string array, or give me an array that has 1, 2, and 3 in it. Or we have, we saw it above, a list of strings. Or is there a collection, actually? Collection? Yeah. string, I should do integer, right? So we can also initialize a collection. We can also have the immutable versions. We can have an immutable array or an, why not? Cannot be used with collection expressions. Interest. Oh, yes, because we are because we're on .NET 6.
Oh,
It requires .NET 8.
that's fair enough.
Because this is also what Stuart showed us. The immutable array actually has the collection builder attribute on top, which teaches this collection initializer or this collection expression feature how to initialize, how to build this collection, which means we can also build our own collections using this attribute and also use this C# feature. Basically, we can tell the compiler, in order to support this feature, please use this create method to enable this feature for any collection. And well, this doesn't work on C#6 on .NET 6 yet, because .NET 6 doesn't have this attribute yet. So it only works on .NET 8. And we can also have immutable list, immutable dictionary. No, dictionary not yet. Dictionary may come in C#13, but an immutable list, for example. And again, we could also do it empty.
Yes. And I think that's what we used quite a lot in our project, didn't we?
Indeed.
And what is this?
Yes.
Do you also want to have a look at this in SharpLab? Like, what is this actually?
Indeed. Yes.
I read your thoughts. I saw it on your face. You haven't been in SharpLab for a while. It's like an addiction. SharpLab every day.
It is.
Yes.
I'm a SharpLab-aholic, I guess. Okay. Let's say we have a string array. And we say this brackets. So because the compiler is aware of this feature and it does the most efficient thing, it just says array.empty. And it does not do like create a new string array like so. Because creating a new empty string array like this, every time, if we do this 3 times, we actually create a new instance of an empty collection every time. But an empty array, we cannot add to it, and it has 0 elements, so we cannot edit anything. So it's really immutable. And therefore, it's more efficient to use array.empty. Oh, I need the using system because we don't have implicit usings. Array.empty, which basically only initializes it at startup a single time and then reuses the same instance for these as well. And this compiler feature is aware of that and actually uses here the array.empty, which is super cool. And if this was an immutable array, it cannot be of static type. So yes, it needs to be immutable array of integer. It uses immutable collections Marshall as immutable array, so it knows how to most efficiently create this immutable array. So it's really the best thing to use that because the compiler knows how to optimize this the best.
I love those things. The compiler knows, I don't have to know. I just do like some brackets and done.
There's also spreading that you can apply. You can have like an array 1 that has 2 and 3, and then have like here element in the second array element 1, then spread array 1 and 4, which should now result into actually 1, 2, 3, and 4, because we have the 1 from here, the 4 from here, and the 2 and 3 are coming from there. So there's basically with the spread operator are combined into 1. Is this drawing weird? I guess so.
Yes, it is. I was going to say. Merry Christmas, everybody. Yeah. Okay, but can we actually see that? Should we print it, or can we see it on the right-hand side?
So can we
1, 2,
do?
and 3?
Sure. Let's for each these. Let's go
Because
over
I
array
don't
number
believe
2.
that without
We don't-
proof.
Oh, it's item. That's fair. And console dot white line item. And let's run that code. And we have 1, 2, 3, 4.
1, 2, 3, 4. Okay, awesome.
And if we only do array 1, that's the 2 and the 3. And if we do array 2, but don't spread, then it is just the 1 and the 4.
Awesome. Cool. Should we have a look at like some examples on where we use that in our code, or is that? I mean, it's always the same. It's just like empty brackets. But it was like a
we use
lovely pull request where we just got rid of a bunch of code all in one. It was pretty cool.
Should we take a look at the pull request, actually? Maybe this reveals the difference more
If you
nicely.
find it, I mean, go for it.
So
One
this
thing you'll notice
use-
about our streams, like it's all live. It's all sort of like what we come up with at the time. So yeah, let's try that.
So let's scroll down a little to, yes, so basically here where we get rid of the creating a new string array for the arguments that we pass into our integration tests, basically just as we would put on the console, putting in the using globalize command. And we, oops, let's just, so I can't zoom in. Yes. And we can get rid of this new array specifier and just put it into brackets. And the compiler knows we want a string array and does the right thing.
Yep.
And also we have this a lot. We actually use this heavily in our unit tests. There is even more. If zooming works in somehow. There we go. Where we now we no longer use, what's this called? Array initializers or collection initializers. We now use collection expressions.
Nice.
And
Well
there's
done for
actually
learning
one.
that.
There's actually one.
I was like curly braces and angle brackets. That's it. I'm not even sure if that's right. Oh my god. I really need to get my English terms right.
I think the angle brackets are
Oh no,
these, the less than and
no.
the greater than
What are
symbol.
they? We had that in the last stream as well, and somebody actually from the audience told me then what it was.
Just
anyway,
brackets.
Square brackets.
Square brackets, yes.
That was really loud. Sorry.
we also use the C#12 type using type alias, type using alias, using type using alias, I think. And we also use primary constructors. So this is pretty cool. Let's jump into that file. So what we have, this is just a regular class. It looks like a record. You could do something like this in a record already, but now something similar, not exactly the same in classes as well, where we basically can in a parameter list define our arguments that also create this is what a feature is called, primary constructor. And now this directory is for us available in the entire type, so we can just return it. We didn't have to, what we got rid of is the boilerplate of creating ourselves a constructor, and in that constructor assigning this to a field, to an instant field, and then use it. And we boiled it down to, well, having the constructor and assigning it implicitly, and so we just use it down there. Got rid of a lot of boilerplate code.
Yep. Awesome.
And one, yes, no, that's actually what those 3 features that we use heavily now from C#12.
Yeah, totally. I mean, we still have a little bit of time left. Would you like to kind of jump into the tests a little bit and see what we did there?
We are quite proud of our test suite, aren't we?
Yeah, we are. With good reason, though, I think.
We can, we mentioned the MS Build workspace earlier. What we have for our unit tests, because we don't want to, for our unit tests, you don't really want to create a project file on disk, but just have it all in memory. And what we use for that, if we jump into our helper methods that have expanded over 22 episodes, we have, instead of the MS Build workspace, we have an ad hoc workspace. And it works basically the same as an MS Build workspace, but it's not based on file system, CS projects or solutions, but we can basically create our workspace and projects ourselves in code in memory. And it's again the same structure. We have a workspace, we get a hold of the solution, we add projects to this solution, and then we add documents to this project to again fulfill the hierarchy, this Roslyn hierarchy of projects and documents. And we always, I guess one thing to mention, in Roslyn, everything is immutable. So this is why we always assign the result of some Roslyn operation to the original variable again, to override it with the new thing, because almost every method in Roslyn does not modify the original instance, but then creates a new instance and returns that. So we want to always use the new instance. And so we build up our projects in code ourselves, and now have, for example, for our using directives, do we have a simple test? Yes. So this is our using counter. We have two documents. A document, well, it's called a document because it's not necessarily a file on disk. In MS Build land, it's a file on disk. In the ad hoc land, it's just something in memory. So the abstraction over, for example, a C# or Visual Basic file is a document. And in these two documents, we have two top-level using directives, and we expect, again, with the new collection initializer feature, we expect that we find one system directive. Well, we find actually two system directive usings. And then we run our code, and we assert that indeed we found those two usings. And we do this very similarly with globalizers. Just scrolling to one test, maybe one that is not too big. Perhaps this one.
Good luck. Yeah, that looks really good.
So we have in the original project, well, we always adhere to the arrange, act, and assert phase. And in the arrange, we first create our project under test, again, via the ad hoc workspace, so all in memory. It has a couple of usings. Then we create our expectation, because if we globalize system.collections.generic, we expect system.collections.generic to disappear from the output project, but reappear in an additional document with the global modifier before it. And then we run our code, assert, and everything is cool.
Awesome.
But we also have integration tests. So we do the same thing, or most of the things also for integration tests, where we actually create files on disk. So for our integration tests, we created ourselves our base type that enables so basically some infrastructure setup. It helps us create this MS. It helps us find because now we are in file and MS Build land. Now we actually create files on disk. So we need the MS Build workspace, no longer the ad hoc workspace. It's really an integration test that runs the command. It also includes system.command line. It basically includes everything. So we need the MS Build version. We create a test console, not the real console. We don't physically print to the console, but we want to get a hold of the output so we can assert that the expectation that is printed to the console is actually what we expect. We create ourselves a Scratch directory. So in our artifacts directory, this is also where we have the test results. We have all of our test projects that we create. We also have a .NET abstraction, so we did this like in the last stream, we can do .NET New and .NET Restore in our integration test as well. and we have a result that we can assert with the output and the exit code, where exit code 0 indicates success and execute everything else, then 0 indicates an error. And then we basically create a project. We add some documents to it, and this is then eventually, when we initialize, now really creating files on disk. So we have some, where can I find that? We then actually go into write methods, where we actually do file.write.text. So physically, in our integration tests, physically creating the project as an input. And then afterwards, because for example, our globalizer is changing the project, then afterwards analyzing this project again and see if it has changed to our expectation. And with that, we should have actually a pretty good code coverage. And code coverage is also something that we will explore then in the next season.
In the next season. But I think it's been quite a fruitful year. I don't know about you, but I'm really proud, to show this stuff to you today. And also, I think I learned a lot just in the last 12 months. And the most important thing is that I had fun doing it and, met new people. And also because the community supported us so much. Because I think we have one more person we wanted to mention that who helped us also build this, who fixed one of our bugs.
Is it here? Yes. So here we have our contributor list. Well, this is only the direct source code contributor. Well, only is an understatement, but this is the direct source code contributors and the guests we had in our show. And off the show, Ghostwalker helped us fix one of our pipelines. But we also had, as you mentioned, we had a lot of help from the community doing our live streams. I guess preventing bugs even getting into our code base in the first place before we committed.
And also giving us ideas about, again, to-dos and new things and new content. And this is why I said, I'm not worried about us ever running out of content. I don't think that's possible.
We have currently 47 issues open on the site during this stream. Well, it will be 49 afterwards because we'll be adding 2. I guess we are, is there some burn down chart? We are adding more issues than we're resolving, aren't we?
Yeah.
So this is our never-ending project.
Cool. It is, indeed. No, but it's fun, and it's, it's not about it's about the journey, not the finish line. I don't know. I don't actually know what this is, but you learn something, and I think we have a pretty good pre-release tool, and we keep adding towards it and making it actually something that people might use. So if you don't have a Christmas present for somebody, you can send them the link to our new Nuke package, and you can enjoy our .NET tool this Christmas.
Matthew's helping us with the saying. It's about the journey, not the destination.
It is. Thank you so much. And awesome. Speaking of which, again, big thank you to the C# Advent Calendar. And if you sort of get a little bit bored during the Christmas period, please check it out. There's so much content there. You can learn something, even if you don't get bored, just if you want to check it out, actually. Every day there's content, and and really, really interesting people from all around the world helped put together this Advent Calendar. So big thank you again. We're really grateful to be part of it this year. And and also grateful to be able to check out all the other content.
I'm not counting. It's Christmas depending on the region, it's Christmas in 4 or 5 days already. Oh, wow.
It is. Yep. Yes. This year passed quickly, but that's time passes quickly when you're having fun, right?
Eric, thank you for a great Advent Calendar part. Merry Christmas and happy holidays. Thank you so much, Eric.
Thank you so much, and happy holidays to you and everybody here. What's new? What's going to be?
Hold on, one more. Yes. Thank you, Matthew, for having us. We really appreciate the opportunity to be on the prestigious C# Advent Calendar.
Yes, thank you so much.
This is the first live stream ever.
Are we? Oh my god! That's so cool. That just made my day. Oh, wow. Yes. You need to put that. Yeah, we need to publicize that. Put that on our achievements of the year.
Oh, yes.
Awesome. Cool. And what's next from us for next year? Other than we'll have our regular stream, and we'll tackle some of those issues. We might have a jingle. We might have a better updated stream.
Yes.
Anything
Yes.
else that we missed? Loads of new,
Um,
we've got a list of guests that we want to invite as as
Yes,
we're
indeed.
constantly in talks with them, which is also like the super fun episodes if you get an expert on one field and get to learn from them and with them and explore stuff. So yeah, I think we have a good year ahead of us.
Oh, yes, I'm quite looking forward to 2024.
Yeah, me too.
But also looking forward to giving 2023 a proper finish over the
Proper send-off.
Christmas, proper send-off over the Christmas and New Year season. Yes.
Yeah, same here. Awesome, Noel. Thank you. If that's everything we wanted to tackle in this stream, right? Or do you have
Indeed.
any more
Yes.
points?
We're about to sign off.
Done.
We're about to go on holiday.
We're about to go on holiday. So thanks again to all of our viewers. Thanks so much to our regulars. We really appreciate seeing you again. But also, if you've been here for the first time, thanks for joining. And we hope to see you again. We usually do a lot more live coding. We literally built this all live on air. You can also check out our videos on our YouTube channel, or you can follow us on our social media platforms if you want to get in touch and reach out and give us feedback or new ideas. Yeah,
just
put the links in there.
In there, yes, in the chat. Oops, I meant to show this one.
Yeah, Christmas trees. It's time for the vacation. So thanks again from my side, and happy holidays.
We'll be back.